Hello everyone, great to see such good turnout. So today I want to talk to you about why I believe we're at an inflection point in the DLT or blockchain space where really entirely new business opportunities are coming into reach. For those that haven't come across Daml or digital asset yet, I'll start with just a bit of context on who we are and what we're doing, but most of the session today will be dedicated to explaining why we are doing what we're doing. Now, the examples I've chosen today are deliberately non-financial and somewhat far out, as they serve the illustrative purpose much better, but everything I'm saying today should fairly obviously be transferable to financial or other industry applications. So let me start with that bit of context. Daml is an open source tool stack developed by Digital Asset to allow developers to build and deploy distributed applications. We want to enable developers to build value, and to do that, they need to be able to put the application first. And today I'll explain what that means and why that matters. The first pillar of this is to abstract away the infrastructure so that developers can concentrate on generating business value and write the applications once and then just deploy it wherever fits, a DLT, blockchain, cryptographic database, or any other backend system. The second is that we want to bring agile to such applications, iterative scaling all the way from a POC built in days to the scale of national infrastructure. Third, we're trying to give developers the tools to build complete applications, including integrations, automations, user interfaces. Smart contracts running on a blockchain are only a small part of applications. And lastly, we're making cheap, fast and complete deployment targets available. In other words, we're trying to make the road to production as smooth as possible. Now, in all this, I'm talking about distributed applications. And before I go on, let's see what I mean by that. Now, many might be thinking, well, we're talking about applications running on blockchain, but that's not a good definition. We don't usually classify applications by the infrastructure they run on. I would say that a distributed application is one that has some of the following characteristics. It's distributed in terms of infrastructure, i.e. it doesn't run on a single physical machine. And if you're in software engineering, you'll know that every large application nowadays falls into that category. The next is distribution in terms of trust. We remove the central point of trust. There no longer is a central party through which all information flows. Messengers with end-to-end encryption are a good example, where we remove the operator's ability to read our messages. The third is distribution in terms of control, systems where no single entity has the power to materially disrupt the whole network. The internet itself is a good example of this, or distributed social networks like maybe Mastodon. And the last is distribution in terms of knowledge, and this goes in the direction of privacy, where information only flows to real stakeholders of that information. And here, traditional peer-to-peer messaging is a good example. Email. Your email only gets read by you, by the receiver, and the few people that route it in between. Now you'll notice none of these applications are new or have anything to do with blockchain. Indeed, most interbusiness and even intra-business applications need most or all of these properties. And that's why so many systems nowadays are message-based. But message-based systems, we know, are error-prone, require a lot of data duplication, and heavy reconciliation, which is expensive. And this is where blockchain's great innovation comes in. Blockchain contributed consistency and integrity for such systems, which removes the duplication, removes a lot of the error scenarios, and removes the need for reconciliation. On top of that, smart contracts gave us a nice mechanism to gain shared understanding of the rules of such systems. Now, nowadays, we really often just say blockchain to mean any platform that adds these eventual consistency guarantees into the mix, or distributed or decentralized application for applications running on these platforms. But what I want to point out here is that this technology is really just bringing new important properties to an existing category of applications. We don't need to invent new blockchain applications to get value of the technology. Rather, we need to get the technology to a point where it can start supporting these existing applications. But let's start with a traditional blockchain example. Next slide, please. and that is digital money or cryptocurrency. Now, I would characterize this application as follows. It's a very high value application. Payments are big money. You could even argue a matter of national sovereignty. Controlling money gives you enormous power. Money has all the properties of distribution that we just discussed. Bitcoin may be lacking the privacy, but that's an implementation problem. Money has privacy. Consistency, the main property blockchain gave us, is crucial. We all know how expensive forgery and fraud are in the real world. And it's a very simple application. The state of this application is just a fixed or controlled quantity of assets allocated to addresses. And the state transition is just a quantity preserving change to that allocation. There's nothing more to it. Everything else on blockchain is just there to incentivize the operation of the infrastructure and the enforcement of those rules. Yet a bit of research I did showed that earlier this year, there were a good 5,000 carbon copies of this application running, forks, copies, just small incremental changes. And almost 850 of those were running on their own dedicated infrastructure. I don't know any other example of an application that was copied that much. And indeed, many other applications that we're talking about on blockchain are closely related. Blockchain is still very closely associated to digital assets. That tells me that people see the value in the technology, but find it challenging to move beyond those core use cases. Why is that happening? To understand that, we need to look at the cost and value associated to technology stacks. Next slide, please. If we look at technology stacks, and blockchain is a good example here, cost and value are almost inversely proportional to each other. Starting from the bottom, building robust infrastructure is very expensive. We're probably talking in the many tens of millions of dollars to build something. Then running that infrastructure is expensive. First of all, it's not available to most of us. Then you need specialized personnel and skills. The software doesn't have the same production readiness as more traditional infrastructures, and there are no managed offerings, which would make all of this easy. Then we have to program them at a low level, often at the protocol level. So we have to redevelop a lot of libraries and tooling for even simple applications. Only once we've done all of that, we get to the business logic, which ends up being a tiny fraction of the cost of our projects, but delivers all the value. And if we look at the blockchain technology landscape of the last decade, we were almost forced to start close at the bottom of this pyramid. So getting a distributed application to market was prohibitively expensive and led to a lot of early commitment. If you discovered you'd gone wrong anywhere in that process, you had a large amount of sunk cost and you had to start from scratch. So we couldn't validate business cases until we'd made big investments. In that environment, only the simplest, highest return on investment applications make sense. Hence cryptocurrencies, high value, simple, and hard to do any other way. Or indeed, we just heard about supply chain management. It's again, a very, very high value application. And to really make it work, you need to shoot for the moon. You need to go global. Now, cutting the investment by forking, cloning, or making just small increments can change that equation dramatically, which is why we've seen so many copies of the same things. Now, clearly, all of this hinders innovation, experimentation, and adoption. But today's talk isn't meant to be negative. As I said in the beginning, I think we're at an inflection point where all of this is changing. And to see why, let's look at some historic parallels. What do mainframes in the 1960s, databases in the 1990s, and blockchain in the 2010s have in common? Every new generation of infrastructure starts being very low level. Every time there is a race to build that ultimate infrastructure. So we see a rapid expansion in new offerings hitting the market. And every time after that initial explosion comes a consolidation. And that consolidation comes at the point where the infrastructure is abstracted away, becomes commoditized, and applications become the focus. And that's when the real innovation starts happening. In the 1960s, that happened for mainframe applications with COBOL. In the 1990s, ODBC did that for CRUD applications. We saw it again in the 2000s for service-based architectures with standards like REST and JSON, and for cloud-based architectures in the 2010s with containerization standards like Docker. And this is exactly why one of the main pillars of Daml is abstracting away the infrastructure. We need to take exactly this step for distributed applications. So how does that change the cost equation? Next slide, please. Once the infrastructure is mature, commoditized, and just interchangeable, you no longer need to commit early. There's no lock-in, and you have easy access to managed offerings. And we're seeing that happening in the blockchain space, with large tech companies coming into the space and offering properly productionized DLT infrastructures. And of course, that's exactly the sort of infrastructure we're targeting with Daml. Next, practices for tech ops are starting to emerge, and skills and personnel get available. One thing that helps here, as I said earlier, is the availability of complete managed offerings, which is why that is one of our focuses. But it also just takes a few major projects to be completed so that the professionals from those projects hit the open market and can be hired. Then, of course, we need to have higher level abstractions, languages, libraries, tools, and frameworks that make it easy to get full stack applications off the ground and get POCs done in days, which is, again, one of the core pillars of Daml. Once all that has happened, developers can start focus on the application logic, the code that differentiates them and brings value to the customer. In other words, you can start from the top of the pyramid, safe in the knowledge that everything else can follow easily. And what opportunities does that open up? As I alluded to earlier, it means that we can bring the benefits of the technology to all kinds of distributed applications that we already know about. And I'll start with an example that might strike you as a little bit silly here. Project management, Kanban in particular. It's not so important what Kanban is. It's illustrated in the picture on the top right here. The important things are, it's not that high value business. The market leader was recently sold for $425 million US, so it's nothing like money. Also, it's just usually a centralized application. Trello or Jira or tools like that are just server-based. They are, on the other hand, highly complex compared to money. Lots of features, automations, integrations, and so on. So completely different sort of application. So nobody would usually think about these as blockchain applications. But indeed, once you get into buy or tri-party projects, there are strong distributed components, especially around trust, knowledge, and control. A lot of sensitive information gets shared on these. We're just so used to these applications being centralized that we've learned to work around these limitations by setting up multiple boards or just agreeing that one party can have control of everything. Now, you may be wondering, what would be the business model of a distributed project management system? And the point is, I don't know, but until today, we couldn't really find out. Maybe there are opportunities to manage nodes because not everyone needs on-prem, maybe in directory services, maybe just in great UIs like has happened in email. Maybe it's network provision or it's the same business model as for the centralized version in value-add services or marketplace. But you can't find out, well, you couldn't find out until today. On public chain, you can't compete on the transaction fee market, and you certainly don't want to develop your own platform just for this application. And deploying and running enterprise blockchains was prohibitively expensive. Today, the combination of tools, abstractions, and infrastructure moved this very much into the realm of the possible, as illustrated by the open source Open Work project, which is a suite of productivity tools, including a distributed Kanban. Now, whilst this sort of thing is coming into reach, it's still somewhat far out there. So let's have another look at something much closer to where people's thinking is already at with blockchain and distributed ledgers, and that's social networks. Social networks undoubtedly are high value. Facebook is currently valued at $500 billion US. These applications also feel very distributed because all interactions are peer-to-peer. But we are all painfully aware that they are in reality highly centralized, with business models focused on selling people's data for advertising. So it's no surprise that there's a lot of interest in distributed models. And to illustrate that, I've included here a picture of Definity's recently launched linked up professional network on their platform, or Jack Dorsey from Twitter calling for decentralized standards for social networks. Indeed, interest here is strong enough that new business models are being explored on blockchain, typically around cryptocurrencies. Examples here would be Mines or Steemit. But there are two key questions that sort of spring to mind here for me. Firstly, is blockchain in the proper sense of the word actually a good infrastructure for social media? And secondly, are the business models driving the infrastructure decision here or vice versa? And I would argue that the business models are being retrofitted to the infrastructure. Blockchains are chosen because that's what's out there, and business models are centered on tokens or cryptocurrencies because that's what the infrastructure provides. Only when we properly decouple the application from the infrastructure and we have available cheap managed infrastructures, exploration of a much wider range of opportunities and business models for applications of this type becomes possible. Now, whilst we're on social media, let's also talk about how such applications are brought to market and scaled. According to Mark Zuckerberg, the first version of Facebook took 2 weeks to develop. They then iterated that application for quite a long time before they had to rebuild. In other words, they followed a truly agile approach. Now, Agile, Scrum, and similar frameworks are all about minimizing risk by approaching solutions quickly and iteratively. Every development cycle accumulates risk and cost, which is why keeping cycles short is important. You want to have the ability to change your mind and validate what you're doing. And that process needs to be able to take you to scale. But if you contrast that to the blockchain world of 2020s, you understand why such applications weren't built. You needed to commit early to an infrastructure, and the lack of tooling made it very expensive to even build an MVP. So, the whole MVP concept didn't work well. Next, you have the problem that blockchain applications are designed to be almost unupgradable, right? They are meant to be an unchangeable contract. And lastly, even if you got the initial version of your application right, even simple applications like Steemit or CryptoKitties needed to build custom infrastructure before reaching any real scale, just because the infrastructure wasn't ready. And all of that just adds up to risk and more risk. And this is where the last of Daml's pillars comes in. To allow rapid development of POCs and iteratively scaling them to significant size, we need that infrastructure, we need upgradability, and we need the tooling. We need to allow developers to be agile to scale. Now, already with the developments I've discussed so far, I believe a wealth of distributed applications can benefit from the innovations brought by distributed ledgers and smart contracts and unlock all kinds of new business opportunities. But there's more to come. I've talked quite a bit about abstracting away infrastructure today, but abstracting away infrastructure for distributed applications is actually not the same as for databases or mainframes. Imagine, next slide please, sorry. Imagine.
Bernhard, I just wanted to remind you that there's just 5 minutes.
Yeah, I've got 1 minute left.
This is your last slide. Great.
Imagine you had a distributed trading application. One participant runs Fabric, one Ethereum, one Corda. Even if the application runs on any of those, they may not talk to each other. Today's interoperability solutions often revolve around intermediaries, i.e. complex Oracle services that move data between platforms, but that diminishes the benefits of consistency, integrity, and the shared rules considerably. So in the early 2020s, you'll see a lot of innovation in real interoperability, i.e. applications that can span multiple infrastructures seamlessly. And the current infrastructure abstraction Daml offers, which makes applications portable between different platforms, is an important stepping stone in that direction. And you'll see a lot more of this in the months and years to come. So with that, I'll finish and hand back to Enrico. Thank you.